Okay. In this video, I will quickly go through the important concepts in Module 11. Okay, let's start. First of all, I wanted to know how to distinguish between like direct variation or inverse variation. So first of all, when we compare the two value of the variables like this, when x equal 1, y equal 4. If I double the value of x, become 2. Then the value of y also double, become 8, right? If I triple the value of x, 3, and you found that the y value also triple, become 12, then we can say this direct variation, okay? If x double, y also double, then it's direct variation. Okay. What is inverse variation? If you double the x, then you found the value of y become a half. So become 24 half become 12. And then you found if you triple x, you found the value of y become 1/3. So 24 divided by 3 is 8. So 1 times 3, the other divided by 3. Then we can say the relationship between x and y is inverse variation. And usually we'll write s times y equal a constant. This a is a constant, or y equal a over x. So in this example, x and y is inverse variation. What is a constant? A, you just found the product of x and y. You can see the first column, 1 times 24 is 24. The second column, 2 times 12 is also 24. The third, 3 times 8 is 24. So you see the product of x and y is always a constant. So when we say x equal 4, you know y equals 6. When we say x equal 12, then y equal 2. So you can, if you know x, y is inverse variation, and then you found the constant, then you can find the value of x or y when you know the other one. Here is an example. If I say x and y is inverse variation, when x equals 5, y equals 6, how about when x equals 3, what the value of y should be? So you found the product of f, x, and y. So 5 times 6 is 30. That means no matter what, the product of x and y is always 30. So when x equals 3, y equal 10. Y equal 10. All right, this is how to distinguish between direct and inverse variation. Okay, this just like you guys. Okay, I don't want to see your face like this. I saw that a lot. Okay, the second important is to graph. Is important concept to graph. So you need to know how to find the y-intercept of the graph when I draw this, right? Okay, so what is y-intercept? You plug in x equals 0 to y, found y-intercept. So it will be 2 times 0, 0 plus 3, and then 0 minus 4 times 0 plus 3. This 0 over negative 12, so that's 0. So y equals 0. So the y-intercept is 0, 0. So the graph goes through the origin. And then how to find horizontal asymptote? Horizontal asymptote is you plug in x equal infinity and y equal to that value is horizontal asymptote, right? For here, you can say 2x, x plus 3, x minus 4, x plus 3. First of all, you can cross out this x plus 3. So this is f of x. So that becomes 2x over x minus 4. And to find the horizontal asymptote, you plug in x equal infinity. So it becomes 2 times infinity over infinity minus 4. All right. Whenever you see infinity plus or minus a value, you can just ignore the value because infinity is too huge. No matter we plus 1 million or minus a million, will not change the value. So this equal infinity, or infinity minus 10 to the power 9 is still infinity. Infinity is the number cannot be changed, or it is always infinity if you plus or minus something. So infinity minus 4 still infinity. So that will be infinity for the button. But 2 times infinity still 2 infinity. Okay, you cannot 2 infinity is not infinity, but you just said right 2 infinity anyway. And then you can because the top, both the top and the bottom, they have infinity, so you can cross out, so that equals 2. So what it is tells us that means when x approaching infinity, y equal 2, that means the horizontal asymptote is y equal 2. So y equal 2 is a flat horizontal asymptote, y equal 2. This for horizontal asymptote. And for vertical asymptote, you found the value will make the denominator become 0. So because here x minus 4, so when x equal 4 is the denominator becomes 0. So that's your vertical asymptote, x equal 4. And then you can draw the graph, should be like this. This, use a calculator, double check, right? And this is horizontal and vertical asymptote, right? And also it will ask you the domain of the function. That's the third question. So the domain of function, you need to look back the original function where the value of x will make the denominator become 0. So first of all, you can always write x. For this kind of function, you can write x belongs to all real number. X can be any real number. However, x cannot be 4 or cannot be -3, because if you x equal 4, you make this become 0. If x equal -3, you become this part equals 0. So that's why x can be any real number except this two value, 4 and -3. So there should be a empty hole here, x equal -3, right? Okay, let's see another example. I think the new concept is how to find a horizontal asymptote. Like I said, so I repeat again. You use x equal infinity, plug in here to find the horizontal asymptote. So how to do that? It will be -4 plus infinity, 2 infinity plus 6. Just like I said, infinity plus 6, plus or minus a value doesn't matter. You just take it out. Get out. So become 2 infinity. All right, this you can change place. You can say infinity minus 4. Again, minus 4 doesn't matter. Infinity, not afraid minus 4, still infinity. So, and then cross out infinity here. So become 1/2. So the horizontal asymptote of this function is y equal 1/2. Okay, you can type this function in the calculator and then you will find something like this. No, sorry. Maybe like this, and then y equal 1/2 is a horizontal line just between these two graphs. All right. All right, that's it. If you have any questions, please let me know. Okay. I hope you can do well this week. See you.